Again, we will be moving online for our next presentation, this time towards the brother project Bizeolcat. The topic that will be discussed is the techno-economic assessment of the new technology developed within the Bizeolcat project, propane and butane dehydrogenation and propane aromatization. We have Vittoria Consentino already connected. Welcome. Hi. Okay. The connection seems perfect. Thank you for joining. A few words about our next presenter. Vittoria Consentino is a strategic research and development engineer at NEXTCHEM, Rome, Italy. She graduated cum laude at the University of Salerno with a thesis named Hydrogen Production from Bioethanol through Autothermal Reforming with Membrane Reactor. She is actively involved in the execution of European Union-funded projects, and her research is mainly related to the decarbonization and innovation of hydrocarbon processes and hydrogen production. Further, she will present you the focus result of her research, evaluation of cost of production of the main product and comparison between the new technologies and relative benchmarks. More will explain and present to you now, Vittoria Consentino. Passing the voice to you. Thank you.
Okay, thank you, Veronica, for your kind introduction. I hope you can see my screen. Okay, so hello to all. I will give you an overall presentation on the techno-economic assessment of Bizeolcat new propane and butane dehydrogenation and propane aromatization. So we will see a general introduction on the state of the art of these three processes and the difference between benchmark and innovative technologies. And then we will focus on the techno-economic assessment with the evaluation of the cost of production and different sensitivities analysis to better assess the Bizeolcat technologies. So the aim of the Bizeolcat project is to evaluate the production of high-value chemicals from alkanes. The three main products analyzed are propylene, butadiene, and BTX, that is benzene, toluene, and xylene. Today, propylene and butadiene are mainly produced from steam cracking process as a byproduct and FCC process. These technologies present high energy demand and low selectivity towards olefins. Since the olefins demand is increasing, on-purpose technologies are becoming more and more popular, and among these we find the catalytic dehydrogenation, which is precisely the dehydrogenation of the alkanes in the alkenes. Even if the process compared to the steam cracking is optimized, it still presents some problems due to the endothermic nature of the reaction and mainly to the formation of coke and the consequent need to regenerate the catalyst. With reference to BTX production, today the main processes are based on catalytic reforming of naphtha and also in this case on steam cracking. The reaction path is strictly dependent on the type of the catalyst used, and also in this case one of the main issues is coke formation and therefore the catalyst deactivation. To overcome this limitation, we try to develop within Bizeolcat project new catalyst and new hydrogen perm-selective membranes. The introduction of the hydrogen perm-selective membranes allows to remove the hydrogen, of course, from the reaction, and in this way shift the chemical equilibriums towards the products, enhancing the product yield. So this is a general overview, For our technical economic assessment, we decide to consider as process benchmark cut-off-in technology for PDH and BDH that we can see in the schemes, and we can schematize as a pre-feeding heating section, a reaction system, and a downstream separation section, in which in the first separation unit, the light compound separation, we also remove the hydrogen. For the aromatization, we choose the cycler technologies as benchmark that we can see as the same main block unit of the other two process. The catalyst considered for the three processes are commercial catalyst, chrome-based catalyst for PDH and BDH, and a gallium-promoted zeolite for aromatization. The innovation that we have brought to the process, as said before, concern the reaction section. In detail, the new PDH is based on a new fluidized bed reactor with double skin membranes and a new platinum tin-based catalyst developed within the project. The new PDH is based on a new membrane reactor but with commercial catalyst, and the new propane aromatization is also based on a new fluidized bed reactor with a new catalyst always developed within the project, but without membranes. The detail of the catalyst were already explained in our previous presentation, and I won't go into much in detail on the new schemes and the design of all the items to lack of time. So let's focus on the main results of our analysis. In the chart, we report the main index for the economic analysis. The black columns refers to benchmark technologies, and the white columns to the Bizeolcat process. The first index is the variable operating cost. The variable operating cost is mainly is based on the feed consumption, and what we can see is that we have a reduction in feed consumption due to the new building blocks and the optimization of the schemes, and this reduction in feed consumption allow a reduction in the operating cost of 18% for the propane dehydrogenation, 30% for the butane dehydrogenation, and the 50% from the aromatization of propane. Looking at the CapEx, we estimated the fixed capital investment based on our experience as an engineering company, starting from the equipment cost of the sixth process. Based on this value, we estimate the depreciation as the 10% of the fixed capital investment and the operating and maintenance of the plant as the 3% of the fixed capital investment. Also in this case, we can see a reduction for the Bizeolcat, respectively of 10% for PDH, 3% for BDH, and 49% for the aromatization. In addition, for PDH and BDH, we also add a new value that is the membranes, the maintenance of the membranes due to the substitution of the membranes each 3 years. By combining all these index, we can calculate the cost of production of the main product as reported in the chart. These are our final results. So we have a reduction of 14% for the PDH, 10% for the BDH, and 50% for the aromatization of propane. After we decide to perform a sensitivity analysis to see how all the impact of all the index on the final cost of production. The first index we analyzed is the feed cost, since we see that the feed cost has an extremely impact on the variable operating cost and therefore on the overall COP as a cost of production. What we can see is that in the all investigated range, the cost of production of Bizeolcat is lower than the benchmark for a propane cost higher than 200 tons, a butane cost higher than 250 euro per tons, and for aromatization instead, we have that Bizeolcat is always more convenient than benchmark. Then we analyze the catalyst cost. In the CapEx evaluation reported below, the catalyst was not included for both benchmark and innovative case. So we performed this sensitivity analysis to see the influence of its cost, but only on the innovative process. Since the benchmark cost reported here is still underestimated. But what we can observe is that to exceed the benchmark case, the catalyst should cost more than 1.5 euro per tons for PDH and aromatization, and more than 6 euro per tons for BDH. Finally, we carried out a sensitivity analysis on the membranes. In the first graph, you can see how the cost of production is impacting by the membrane cost. Fixing a life of 3 years for the membranes, and it's quite evident that the more is reduced the cost of the membranes, the higher is the gain showed by the Bizeolcat process. Then in the chart you see the influence of the life membranes into limit cases with 1,000 euro per square meter and 10,000 euro per square meter. Also in this case is quite evident that the cost of production, that the influence of the life membranes is more evident when the cost of the membranes is higher, and moreover in the case of BDH is more evident respect to PDH, since the numbers of membranes installed inside the reactor is greater. So to conclude, what we can see that from our analysis is that in general Bizeolcat technologies present an improvement respect to the benchmark. These improvements that is basically the reduction of the cost of production is the 14% for the dehydrogenation of propane, 10% for the dehydrogenation of butane, and more than 50% for the aromatization of propane. Of course, the lower is the price of the feedstock and of the catalyst, and higher is this gain derived from the deployment of the Bizeolcat technologies, and in parallel, the lower is the cost of the membranes and the higher is the life of the membranes, and more is evident this gain. And for now, I think that's all. So thank you for your attention, and feel free to ask any question.
Thank you, Vittoria. Please continue staying here with us. I would like to ask the audience if there are any open questions regarding the topic. Okay, so we don't have anyone we do have one.
I'm going to start with a disclaimer that I'm not an expert in this area, but how do you work out the cost of a membrane?
Okay, what you want to know, we evaluate the cost of the membranes, or the sensitivity analysis of on this cost?
Yes, like how do you come up with the the value of the membrane and perhaps the whole impact in the process as well, in cost of operation and.
Okay, what we did is evaluate the number of membranes that we have to install inside the reactor. This is something that came out from our evaluation. The specific cost of the membranes is an input that the partners that developed the membranes gave us, and we take in account so the membrane cost inside the capex evaluation, the total capex evaluation, as a sort of fixed index, a fixed item, but then we also evaluate the impact that these membranes have on the maintenance. So basically we start from the assumption that each 3 years we have to substitute all the membranes that are inside the reactor with the new membranes. So this is an additional cost that we have to take in account. And if I don't know if I can share again the presentation, but what is evident is that in the BDH case, in which we have more membranes than PDH, the membranes have higher impact. So also their maintenance has a higher impact on the total cost of production. But I don't know if I answered to your
yes,
question.
you did very thoroughly. Thank you.
Okay.
Thank you for your questions and answers with the question and answering, Vittoria. Do we have any other questions from the room? We do have a second question.
Yeah, hello. Maybe I missed something. In your conclusions, you say that the Bizeolcat, the technology, the membranes would be attractive if you can reduce cost and increase the lifetime of the membranes. What extra work is needed to reduce the cost or increase the lifetime?
Okay. I answer first at the lifetime because it's easier. What we need, but this is also not only for the membranes but also for the catalysts that were developed inside the project. What we need is, of course, long-term tests to better assess the stability of the membranes. Instead, for the cost of the membranes, the main problem is that today membranes for hydrogen separation are based on palladium, and today is impossible to buy palladium in a, let's say, in a normal price, as also the other materials we have a big increasing in the cost. So of course what we can do is first of all optimize the manufacturing of these membranes, because also if the manufacturing process is optimized, the cost of the membranes is reduced. Then we can also act on the formulation of the membranes, so maybe find some other metals that are cheaper, or reduce the thickness of the palladium, so that could be cheaper, and basically things like that. So in my opinion, we have to both act on the formulation of the membranes, but on the manufacturing in a large scale of them.
So would you say that the material cost is more important or the manufacturing? I mean, if you say it's 50-50 or it's 40-60 or whatever.
In a normal situation, maybe the manufacturing process is more impacting of the materials itself. But today, maybe it's 50-50 because it's like too much higher the cost of pure palladium as pure platinum, and all the other problems that we had with also the catalyst. But of course, having a manufacturing process that is optimized allows us to sell, let's say, the membranes at a lower price.
Okay, thank you.
Thank you very much. Well, speaking of cost, we have, I think, the last question for you. Why the new BTX cost of production is so low respect to the other technologies?
Okay, this is mainly due. First of all, we in the new aromatization case, we don't have membranes because we saw that in the previous evaluation that the membranes in this case have a negative impact on the process. So we only put the new catalyst developed within the project, and this catalyst is so efficient that in parallel it requires less feed, so we reduce the variable operating cost, and also less volume. Therefore, the reactors themselves are smaller, and so the capex is smaller. So it's a combination of these two factors. But as I said before, also in this case, new stability test, long-term test will be necessary to perform a complete assessment of all the novel technologies.
Thank you. I think this answers our question. And meanwhile, yes, with your permission and everybody else's, I will add another question that we just received online. What is the stable lifetime of the Bizeolcat catalyst for propane dehydrogenation? Is the catalyst regenerated or replaced with a fresh one at the end of the lifetime?
Okay, let's say during the project, as also saw before from the other presentation, we don't have this long-term test. In a industrial case, the catalyst is both the effect, let's say, because the catalyst needs to be regenerated each hours, I don't know, this depends of the catalyst itself. Let's say that each 100 hours it needs to be regenerated. So in the scheme we need to include a regeneration section for the catalyst, but all of course after his lifetime, that could be for 1,000 hours, 10,000 hours, we need to remove all the catalyst and add new one. But let's say that the regeneration is considering inside the our evaluation. Instead the removal of the spent catalyst with the new catalyst is something that we not consider.
Thank you very much for the attention brought to our questions today. A round of applause for Mrs. Vittoria Consentino, and thank you for sharing your knowledge with us today.